ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. Welcome to the Department of Collegiate and Technical Education. So in this chapter, that is Unit 3 of Optoelectronic Devices, under this unit we are going to discuss about the liquid crystal display, which forms the session number 24. So welcome you all to the session. So in this session, we are going to cover the following topics, that is the basic construction of liquid crystal display, the working of liquid crystal display, and also few applications of liquid crystal display. So we are going to discuss about these topics in this session. So first, let us start with the traditional display that we used to use in earlier days. That is, you all know that cathode ray tube was one of the mainly used displays earlier. So CRT, it is nothing but a technology used in traditional display as in computer monitors and also televisions. So ಈ cathode ray tube ಟೆಕ್ನಾಲಜಿನ ನಾವು ಕಂಪ್ಯೂಟರ್ ಮಾನಿಟರ್ಸ್ ಅಲ್ಲಿ ಮತ್ತೆ ಟೆಲಿವಿಷನ್ ಡಿಸ್ಪ್ಲೇ ಸ್ಕ್ರೀನ್ ನಲ್ಲೂ ಕೂಡ ನಾವು ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ವಿ. So the technology behind the CRT is nothing but by firing electrons from the back of the tube of phosphorus located towards the front of the screen. So CRT technology ಬಗ್ಗೆ ನಾವಿಲ್ಲಿ ಅಷ್ಟು ತಿಳ್ಕೊಳ್ಳೋಕೆ ಹೋಗೋದು ಬೇಡ. Let us concentrate on liquid crystal display. So ಟ್ರೆಡಿಷನಲ್ ಡಿಸ್ಪ್ಲೇ ಆಗಿ ನಾವು CRT ಡಿವೈಸಸ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ವಿ. ದೆನ್ ವೈ ದಿಸ್ ಟ್ರಾನ್ಸಿಷನ್ ಫ್ರಮ್ CRT ಟು LCD? ಯಾಕೆ ನಾವು CRT ಇಂದ LCDಗೆ ಶಿಫ್ಟ್ ಆಗಬೇಕಾಗಿ ಬಂತು? ಬಿಕಾಸ್ ನೀವು ನಿಮ್ಮ ಕಾಲೇಜ್ನಲ್ಲಿ ನೀವು ನೋಡಿರ್ತೀರ CRT ಡಿವೈಸಸ್, CRT ಬೇಸ್ಡ್ ಕಂಪ್ಯೂಟರ್ ಮಾನಿಟರ್ಸ್ನ ನೀವು ನೋಡಿರ್ತೀರ. ಇಟ್ ಈಸ್ ವೆರಿ ಬಲ್ಕಿ, ಅಟ್ ದ ಸೇಮ್ ಟೈಮ್ ಹೆವಿ ಕೂಡ. And also they used vacuum tube technology, which is an outdated technology now. So hence we shifted for LCDs, that is liquid crystal display, because of their low manufacturing costs. Also they are very light and sleek, energy efficient, they consume power in terms of nanowatts. So their energy consumption is very less when compared to other display devices. And also they have very sharp picture. So because of this, we shifted from CRT to LCD. So then what is this liquid crystal display? It is basically a display technique which used liquid crystals in order to produce an image on the screen. They used this LCD technology used liquid crystals to produce an image on the screen. So nowadays, many of the devices are made up of liquid crystal display, like computer monitors, digital watch displays, your calculators, mobile, smartphones, mobile display, they are all made up of liquid crystal displays. Then what are these liquid crystals? It is liquid crystal, it combines two states of matter, that is solid and the liquid. Andre ಈ ಲಿಕ್ವಿಡ್ ಕ್ರಿಸ್ಟಲ್ಸ್ಗೆ ಸಾಲಿಡ್ ಮತ್ತೆ ಲಿಕ್ವಿಡ್ ಸಬ್ಸ್ಟೆನ್ಸಸ್ಗಿರೋ ಪ್ರಾಪರ್ಟೀಸ್, ಎರಡೂ ಪ್ರಾಪರ್ಟೀಸು ಕೂಡ ಇರುತ್ತೆ. ಅಂದ್ರೆ ದಿಸ್ ಫಾರ್ಮ್ಸ್ ಅನ್ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಫೇಸ್, ಮಧ್ಯಂತರವಾದ ಒಂದು ಫೇಸ್. ಯಾವುದು? ಈ ಲಿಕ್ವಿಡ್ ಕ್ರಿಸ್ಟಲ್ ಅನ್ನೋದು. ಈ ಒಂದು ಮಧ್ಯಂತರದ ಫೇಸ್ ನಲ್ಲಿ ದ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ದೇ ಆರ್ ಕ್ವೈಟ್ ವೆಲ್ ಆರ್ಗನೈಸ್ಡ್, ಬಟ್ ಯೆಟ್ ದೇ ಕ್ಯಾನ್ ಫ್ಲೋ ಲೈಕ್ ಲಿಕ್ವಿಡ್. ಹೆನ್ಸ್ ದೇ ಆರ್ ಕಾಲ್ಡ್ liquid crystals. And because of this unique feature of liquid crystals, they found a wide range of, they found in many of the commercial applications. Now let us look into the molecular structure of liquid crystals. See, this molecular structure and the concept of polarization, it's knowing about these two factors, it is very important in order to know the constructional details and also the working of liquid crystal display. As you can see here, in this picture, this is the molecular arrangement in case of solid substances, and this is the molecular arrangement in liquid crystals, and this is the molecular arrangement of liquid substances. As you can notice here, the molecules in solid substances, they are very well organized and they are very rigid in one particular spot. Whereas in case of liquids, the molecules, they are randomly organized and they are capable of moving one past the other. ಅಂದ್ರೆ ಒಂದು ಮಾಲಿಕ್ಯೂಲ್ ಇನ್ನೊಂದು ಮಾಲಿಕ್ಯೂಲ್ನ ಹಿಂದಕ್ಕಾಗಿ ಮೂವ್ ಆಗುವಂತಹ ಒಂದು ಶಕ್ತಿ ಲಿಕ್ವಿಡ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ಗೆ ಇರುತ್ತೆ. ಸೊ ದೇ ಆರ್ ವೆರಿ randomly organized. But these liquid crystal molecules, even though they are not well organized as your solid molecules, but still they are quite well organized when compared to the liquid substances. But yet they are capable of moving one past the other. So this is the molecular structure of liquid crystals, which plays a very important role in liquid crystal display. And these molecules, most of the substances which exhibits liquid crystal properties of liquid crystals, they consist of long, rigid, rod type or disc shaped molecules. Now let us look into the concept of polarization. ನೀವು polarization ಬಗ್ಗೆ ನಿಮ್ಮ lower classes ನಲ್ಲಿ ಓದೇ ಇರ್ತೀರಾ. ಸೊ ಹಾಗಾಗಿ ಇಲ್ಲಿ ಜಸ್ಟ್ ಒಂದು ಬ್ರೀಫ್ ಆಗಿ ಪೋಲರೈಸೇಷನ್ ಬಗ್ಗೆ ಹೇಳ್ತೀನಿ, ಬಿಕಾಸ್ ದ ಕಾನ್ಸೆಪ್ಟ್ ಆಫ್ ಪೋಲರೈಸೇಷನ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ವರ್ಕಿಂಗ್ ಪ್ರಿನ್ಸಿಪಲ್ ಆಫ್ ಲಿಕ್ವಿಡ್ ಕ್ರಿಸ್ಟಲ್ ಡಿಸ್ಪ್ಲೇ. ಸೊ ಆಸ್ ವಿ ಆಲ್ ನೋ, ನ್ಯಾಚುರಲ್ ಲೈಟ್ ಅಂಡ್ ಆಲ್ಸೋ ದ ಆರ್ಟಿಫಿಷಿಯಲ್ ಲೈಟ್, ದೇ ಆರ್ ಅನ್ಪೋಲರೈಸ್ಡ್. ಅನ್ಪೋಲರೈಸ್ಡ್ ಅಂತ ಹೇಳಿದ್ರೆ they travel, the light waves, they travel in all possible direction, radial directions. ಅಂದ್ರೆ ಮೇಲೆ ಕೆಳಗಡೆ ಇರಬಹುದು, ಟು ಅಂಡ್ ಫ್ರೋ ಇರಬಹುದು. So the light waves travel in all possible direction. So such light waves are called unpolarized. Whereas polarized light, on the other hand, it is the light wave in which the waves travel only in one particular direction. Let us consider this example. See, as you can see, this is the unpolarized light which is scattered in all directions, and here is a polarizer which is also called a filter, whose axis is horizontal. So when the unpolarized end light passes through this polarizer, only the light waves which are parallel to the axis of the polarizer pass. The other directional light waves are blocked. So hence this polarizer is called horizontal polarizer, because it allows only the horizontally aligned light waves to pass through and the other light waves are blocked. So the light intensity is somewhat reduced. Similarly, here is another kind of polarizer which is called vertical polarizer, whose axis is vertical. So when unpolarized light, which is scattered in all direction, passes through this vertical polarizer, only the vertically aligned light waves are passed, the other directional light waves are blocked. So what we get out of the vertical polarizer is vertically polarized light. So in this case also, the intensity of light is somewhat reduced. So with this basic knowledge of molecular structure of liquid crystals and the concept of polarization, we can go ahead with the liquid crystal display. So first let us look into the constructional details of liquid crystals. So in liquid crystal display, most widely used liquid crystal is the twisted nematic type crystal. Because the reason is because these twisted nematic type crystal, they have a naturally aligned molecular structure. That is, they have a naturally twisted molecular structure, and this alignment is to an angle of about 90 degree. As you can see in the picture, this molecule, this is the liquid crystal display, and here is the twisted molecular structure. The first molecule, that is the molecule here, it is vertically aligned, whereas on the other end of the liquid crystal, the molecule is somewhat horizontally aligned. So the alignment between the molecule on the other side and the molecule on this side is somewhat aligned or twisted to an angle of 90 degree. And this twisting or alignment of molecules can be changed with the application of electric voltage. ಅಂದ್ರೆ ಈ ಒಂದು ನ್ಯಾಚುರಲಿ ಟ್ವಿಸ್ಟೆಡ್ ಲಿಕ್ವಿಡ್ ಕ್ರಿಸ್ಟಲ್ಗೆ ನೀವು ಒಂದು ವೇರಿಂಗ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ನ ಕೊಟ್ಟಾಗ ಇದ್ರದ್ದು ಟ್ವಿಸ್ಟಿಂಗ್ ನ ಅಥವಾ ಅಲೈನ್ಮೆಂಟ್ ನ ನಾವು ಬದಲಾಯಿಸಬಹುದು ಅಂಡ್ ಹೆನ್ಸ್ ದ ಇಂಟೆನ್ಸಿಟಿ ಆಫ್ ಲೈಟ್ ಕ್ಯಾನ್ ಬಿ ಕಂಟ್ರೋಲ್ಡ್. So liquid crystal, it consists of a liquid crystal of about 10 to 20 micrometers placed between two glass sheets. As you can see, these are the two glass sheets, and on the inner side of these two glass sheets, electrodes are coated. So one electrode forms the positive electrode and the other forms the negative electrode. And this entire arrangement of liquid crystal and the two glass sheets, it placed between two polarizers which are perpendicular to each other. Andre one side nalli vertical polarizer ಅಥವಾ vertical filter ಇರುತ್ತೆ, ಇನ್ನೊಂದು side ನಲ್ಲಿ horizontal polarizer ಇರುತ್ತೆ. As you can see, the molecular alignment of the liquid crystal is vertical. So on this side we have vertical polarizer. On the other side where the molecular alignment is horizontal, we have horizontal polarizer. Now let us look into the working of liquid crystal. These liquid crystals, they don't produce their own light. They require a light source. So this is one of the disadvantages of liquid crystals. ಅದು ಅದರದೇ ಆದ ಒಂದು ಲೈಟ್ ಅನ್ನ ಅದು ಉತ್ಪತ್ತಿ ಮಾಡೋದಿಲ್ಲ, ಬಟ್ ಒಂದು ಲೈಟ್ ಸೋರ್ಸ್ ಅನ್ನ ನಾವು ಬ್ಯಾಕ್ ಅಲ್ಲಿ ಪ್ರೊವೈಡ್ ಮಾಡಬೇಕಾಗತ್ತೆ. So in the beginning, when there is no external potential applied between the electrodes, as you can see, this is the battery and this is the switch. This is the liquid crystal where the molecules are naturally twisted. On one end, the molecules are vertical. On the other end, they are horizontal. So on this side, we have a vertical polarizer. On this side, we have a horizontal polarizer. And here is where the incoming light is entering the liquid crystal. And this is where the light is leaving the liquid crystal and reaching the display. So initially, let us consider the switch is open, so there is no electric potential applied to the liquid crystal. In that case, when the unpolarized light enters the horizontal polarizer, it becomes horizontally polarized. The light becomes horizontally polarized. So this naturally twisted molecular structure, they somewhat twist the light waves according to their alignment. Andre ಇಲ್ಲಿ horizontally polarized light enter ಆದಾಗ ಈ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಹೇಗೆ ಅಲೈನ್ ಆಗಿದೆ, ಹೇಗೆ ಟ್ವಿಸ್ಟ್ ಆಗಿದೆ, ಅದೇ ತರ ಲೈಟ್ ವೇವ್ಸ್ ಕೂಡ ಟ್ವಿಸ್ಟ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ಈ ಸೈಡ್ ನಲ್ಲಿ ಹಾರಿಜಾಂಟಲ್ ಅಲೈನ್ಮೆಂಟ್ ಇರೋದ್ರಿಂದ ಮಾಲಿಕ್ಯೂಲು ಎಂಟ್ರಿಂಗ್ ಲೈಟು ಕೂಡ ಹಾರಿಜಾಂಟಲ್ ಇರೋದ್ರಿಂದ they just pass through the liquid crystal, and also as they pass through the liquid crystal, they also, that is light wave also, get twisted according to the alignment of the molecules. So by the time the light waves reach the other end of the liquid crystal, they would have twisted vertically. So now the light wave which entered is horizontally polarized light, but by the time it reaches the other end of the liquid crystal, they would have twisted to vertical alignment. And now on the other side, since we have the vertical polarizer, the light waves easily pass through the vertical polarizer and that particular area of the display becomes bright. So you will have a visible image produced on the display. Now let us see what happens when you turn on the switch ಅಥವಾ ಒಂದು electric potential ಕೊಟ್ಟಾಗ ಏನಾಗುತ್ತೆ ಅಂತ ನೋಡೋಣ. So in this case, as you can see in the picture, we have applied an electric potential. As soon as an electric potential is applied, the molecules, they become untwisted. So earlier, naturally they are twisted. Now upon the application of electric voltage, now they are untwisted. So now the incoming light, which is unpolarized light, and they become horizontally polarized because you have a horizontal polarize here. So as the light enters the liquid crystal, these light waves, they pass as it is without being twisted because the molecules now they are untwisted. Hence the light wave also reaches the other end of the liquid crystal without being twisted. Now on the other side we have a vertical polarizer, but the light coming is the horizontal polarized light waves. Hence they are blocked by the vertical polarizer. Andre light waves ivaga vertical polarize ಮೂಲಕ ಹಾದು ಹೋಗೋದಿಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ, ಬ್ಲಾಕ್ ಆಗೋಗುತ್ತೆ. So ಹಾಗಾಗಿ that particular area of the display becomes dark. So when you apply an electric voltage, the display becomes dark. When you don't apply any electric potential, the display becomes brighter. So by the application of electric potential, the molecular alignment can be changed to any angle and hence the intensity of light falling on the display can be controlled. So this is the main working principle behind the liquid crystal. So we have a video here that can show you this concept. So as you can see right now, the molecules, they are twisted, this molecular being vertically aligned and this being horizontally aligned. So when you apply some electric potential to this liquid crystal, what happens? They become untwisted. As you can see here, the molecules are now untwisted. When you remove the electric supply, again they become twisted. Now when you introduce a backlight, let us see what happens. So you are introducing a backlight, source of light. So this light, as they pass through the liquid crystal, they also get twisted according to the alignment of the molecules and hence they reach the other end, which is the vertical polarizer, and they easily passes through the display and the display being brighter. Now when you apply electric potential, the molecular structure, they become untwisted. Now let us see what happens when you introduce a backlight. So now you are providing a source of light. They pass through the liquid crystal as it is without being twisted and hence you will get a darker display. You don't get any image at all. So this is just one single cell. When you put thousands of many such cells together, it will form a complete display. By making on and off the relative cell, you can have a different image produced on the display. When you introduce color filter to this display, to this cell, individual cells, you can obtain colored images on the display and whose intensity can be varied by the application of variable electric potential. So I hope this concept is very clear to you all now. Now let us move on to the various applications of liquid crystal display. ನಿಮಗೆ ಎಲ್ಲ ಗೊತ್ತೇ ಇದೆ, ಎಲ್ಲರೂ ನೀವು liquid crystal display ಇರೋದು ಯೂಸ್ ಮಾಡ್ತಾನೆ ಇರ್ತೀರಾ ಮೊಬೈಲ್ ಫೋನ್ಸ್, ಎಸ್ಪೆಷಲಿ ಮೊಬೈಲ್ ಫೋನ್ಸ್. So liquid crystal displays, they are used in aircraft cockpit displays. Cockpit ಅಂದ್ರೆ ಎಲ್ಲಿ ಪೈಲಟ್ಸ್ ಮತ್ತೆ ಕೋ ಪೈಲಟ್ಸ್ ಕೂತ್ಕೊಳ್ತಾರೆ ಆ ಜಾಗನ ನಾವು ಕಾಕ್ಪಿಟ್ ಅಂತ ಕರಿತೀವಿ. ಅಲ್ಲಿ they will have various display. Okay, so liquid crystals are used for such purposes. They are also used in the screen of calculators, ನಿಮ್ಗೆಲ್ರಿಗೂ ಗೊತ್ತೇ ಇದೆ, and also for displaying images in digital cameras. Television is one of the main applications of liquid crystal display, and computer monitors, they are made up of liquid crystal display, and also they are used in instrument panels. They are commonly used in smart watches, digital wrist watches for displaying time. They are used in mobile screens. You all know that LCDs, they are used in mobile screens, and they are also used in video players. So these are the very few applications to mention with respect to the liquid crystal display. So let us summarize the session, what we studied. So to start with the construction of liquid crystal display. So mainly liquid crystal display, it consists of liquid crystals which is placed between two glass plates which are coated with electrodes which forms the positive and negative potential to be applied, and this arrangement is placed between two polarizers which are perpendicularly placed. ಅಂದ್ರೆ ಒಂದು vertical polarizer ಇರುತ್ತೆ, ಇನ್ನೊಂದು horizontal polarizer ಇರುತ್ತೆ. And the liquid crystal, they have a natural twisting of molecules up to an extent of almost 90 degree. So on one side the molecular arrangement is almost vertical. On the other side of the liquid crystal, the molecular alignment is almost horizontal. So on one end of the liquid crystal where the molecules are vertically aligned, we have a vertical polarizer. On the other side where the molecules are aligned horizontally, we have a horizontal polarizer. So when a light source is introduced, so according to the alignment of the molecules in the liquid crystal, the light source also gets twisted and reaches the other end of the liquid crystal and easily passes through the polarizer, creating an image, creating a display on the display device. Upon the application of some voltage, electric voltage, this alignment of the molecules is changed. So when you change the alignment of the molecules, accordingly the intensity of light also can be varied. So by making use of many such cells put together, we have a display device whose intensity can be changed. Also, when you introduce a color filter in front of the display, you can have a colored image being produced on the display. So we also learnt about various applications of liquid crystal display in this session. So that's all we have for this session. Thank you very much.